Hi everyone, it's Ahmet here. Today I'm going to solve the test 6 and let's start with the first question. As you see, it says given a number of diagonals from a vertex is 9 and what is sum of the interior angles of the convex polygon in degrees. So remember, if I draw any diagonal, let's say this is my diagonal, this is one of the vertex, this is one of the vertex, these are all vertices, blah blah blah, and it ends somewhere here. And let's say, can you see the dots by the way? Okay, so let's say this is N-gon. Okay, and let me choose this point here, let's say A, and let me try to draw the diagonals from point A to this side. As you see, A to A, I can't draw any diagonal. A to this adjacent vertex, I can't draw the diagonal. And after that, I can draw the diagonal. This is other diagonal, this is other diagonal, and so on. And as you see, before it ends, I can't draw the diagonal as well. So this point adjacent, this point itself, and this point adjacent, as you see, three of them, I can't draw the diagonal. So therefore, I should subtract 3 from the n. So this must be 9 because it says given the number of diagonals from a vertex is 9. So n is 12 actually. It says sum of the interior. Remember the formula, it is n minus 2 times 180 degrees, which is equal to 12 minus 2, which is 10. It is 180 degrees. It means the answer is B. In this one, if I draw the diagonal EA, let me draw the diagonal EA. This is diagonal joining two sides, okay? This is diagonal joining two sides, and this is diagonal joining two sides again. So this one, EAC, is an equilateral triangle. This is 2, this is 2, this is 2. Therefore, remember the 120 degrees, 30 degrees, 30 degrees triangle property. What was it? It is 2 root 3. Okay, it is 2 root 3. So what is the area of FAE? So I'm going to sum FAE, area of this triangle, plus area of EAC, okay, EAC. So therefore I can have the answer as something above, okay, something below, okay. So let's look at the area of this triangle, which will be 1 over 2 times, one of the side is 2, the other side is 2 as well. And what is the angle? It is sine, remember this is 120, so it will be sine 120 is equal to sine 60, which is root 3 over 2 plus, what is the area of an equilateral? It is the side square, so it is 12 times root 3 over 4. Remember, a square root 3 over 4. A is equal to 2 root 3. Okay, these are gone. Okay, simplifications. This is root 3 and this is 3 root 3. Therefore, the answer is 4 root 3. Okay. Next one, as you see, DH is the altitude coming from the vertex D and it is a regular pentagon. What is the property if this is the height of the pentagon? Remember, it must be the angle bisector. Okay, and FG is 3, let's say 3K, and CG is 4, so let's say 4K. And remember, legs are proportional to bases. So FD, and I know one of the side is 20, so FD must be 20 minus X. So 20 minus X over 3K will be equal to 20 over 4K. So again, simplify, so it is 15, so X must be equal to 5, and that's it, that's asked in the question. Okay, the next one. Let me extend EF through AB, okay, and remember, if this is angle bisector. This is angle bisector. Remember, the angle here is 90 degrees. It says given ABCD is 90 centimeters square. So one side is 9, one side is 10. So one of the side is 10, and the altitude must be what in order to obtain 90 centimeters square as the area? So it must be 9, okay? And this side is 2, therefore this proportion here must be 7. And then it says, what is the what is AF times FB? Okay, from now on, remember, this is a triangle, and I know the height and I know the base. So 7 times 10 over 2 is equal to AF times BF over 2 again, right? Because these are the this degree here is 90 degree and these are legs of the triangle, so I multiplied them and I divided by 2, so these are gone, and as you see the answer is 70. Okay, I'm going to assign some part of area to those portions, those regions. And I explained the logic behind this in test 3, question 10, okay? Question 10. So if you have some trouble with understanding why I was dividing it 3s, 4s, 5s, and what was the logic behind this, so please check test 3, question 10, okay? Let's look at the proportions. EB is here is equal to 3a. Okay, let's say this is a, so this must be 3a, and these are equal to each other. Okay, let's say this is b, then this is 2b. And remember, the area of triangle is equal to 1 over 2 times sides times the sine, the angle of sine. So remember, angle of sines of those angles are all equal, and 1 over 2 is the constant for all of the triangles. Therefore, I'm going to assign the area according to the multiple of their sides. So let's say this is 2s because 2ba, so this is 2s, 3b1, so it is 3s. So this is 4 here, this is 4, this is 1, so it must be 4s. And remember, this is 2 and this is 4, so the lower triangle here must be 4 times 2, 8, and the upper triangle 8 as well, so the area of parallelogram must be 16s, and it says the area here is 21, so 21 plus 4, 7, 9s. So it is 7s is equal to 21, s is equal to 3. What is ABCD? So it is the parallelogram, therefore 16 times 3 will be 48. So it's my answer. Okay, so similarity is really important to solve those kind of questions. Regular heptagon, and look at here, 1, 2, 3, 1, 2, 3. As you see, AD is intercepted by 3 sides of the polygon, and AE, the diagonal, is intercepted by, again, the 3 sides of the regular heptagon. So look at this triangle. If I draw GC, ABC, okay, again, there are 3 sides here, and again, there are 3 sides here. So what's your conclusion? Which is FGC triangle is congruent to DEA triangle, okay? So therefore, if I can find the area of this triangle, then I would have found the area of the triangle asked in the question. And look at here. Height is given, which is 6, and FC is given, which is 15. So therefore, it is 1 over 2 times 6 times 15, which is 45. Therefore, it's the answer, because remember, they are congruent. In this one of the side is 8, the other is 4, and this is 7, so this is 4 root 3. Okay, from Pythagoras, 7 square will be 49, this is 48, so this portion here, HC, so this must be 1. And again, this is 48, this is 64. So 64 minus 48 will be 16. Root it will be 4 here. And we are trying to find the area of the trapezoid. And look at the proportions here. 4 root 3, and 2 times 4, which is 8. So this must be 60 degrees, this must be 30 degrees, okay? Therefore, the angle here is 60 degrees as well. So now I can find the area of trapezoid. So height is 4 root 3. 1 over 2 times 4 root 3 times the base is 5. Okay, this is 2. So this is 10 root 3. Okay, the area of this triangle 10 root 3. And area of this triangle will be 1 over 2 times 5 times 4 times sine 60, which is root 3 over 2. So this is 5 root 5. 5 root 3. Okay, 5 root 3, 10 root 3, it makes 15 root 3. Okay, in this one, it's a length question. Trapezoid ABCD diagonals AC and BD. Okay, so these are lines or line segments. AC is 10. Okay, this is 10. So this is 10 and BD is 12. So this diagonal is 12. It says what is the greatest integer value for the sum of bases of this trapezoid? If I draw this parallel to AC and extend it here, let's say this is parallel to this one, and I already know that this is parallel to this one, so therefore this must be parallel as well. And remember, this is 12, this is 10, so let's say this is DE, so the length of DE must be 10 as well. As you see, triangle inequality, this is DC here, DC, and this is AB here. So what is length AB plus CD sits between, which sum of them and the difference, which is 2. Okay, so it is 21. So that's the greatest integer value for this sum. Okay. Okay, let's look at the next one. Where is it? Yeah, here it is. It says it's rhombus ABCD and this is perpendicular to this one. Okay, in alternate interior angles, so these are perpendicular. Okay, it is 4, it is 8. So if this is x, this must be x plus 4. So let's say this is 6, so this makes 10. AB is 10 here. Okay. That's perfectly satisfy the condition. So it is 6, 8, and 10. Perfect. So find the perimeter of the rhombus. 4 times 10 will be 40. So that's the answer. Okay. For this one, rhombus. And remember, in rhombus, diagonals are perpendicular and they bisect each other. Okay, perimeter is 60, so 60 divided by 4, which is 15. And AC plus BD is 42, so half it, because AC and BD, okay, half it, so it must be 21. So I must have the ratios. So if I apply Pythagoras theorem, I would have the 15 blah and blah. Okay, that must satisfy the condition, and their sum must be 21. So I automatically think that since BD is smaller than AC, let's say this is 9 and this is 12, because I know a triangle which has those sides 9, 12, and 15, and their sum is 21. Okay, so that's perfectly satisfy the conditions. It says what is the area. So one of the side is 24, the other side, which is 18, and remember I divided by 2, so it is 12 times 18, which is 216. In rectangle, if I pick any point inside or outside the triangle, remember 6 square plus 4 square is equal to 3 root 3 square plus the other side square. Remember, it comes from come from the Pythagoras theorem. So if you apply the Pythagoras theorem, you will have exactly the same equation. As you see, this is 36, this is 16, it makes 52, so this is 27x squared, so it is 25 is equal to x squared, therefore x is equal to 5. Okay, in rectangle, the lengths of OA, OB, OC and OD, that are all equal to each other. Therefore, the angle A and angle B is equal to each other. This is an isosceles triangle. And LK is parallel to EF. Therefore, corresponding angles, and okay, this is 30, this is 60. What is the area? So if I draw the perpendicular here, as you see, it will bisect this side and this side. And I know AE is equal to FB because EF will be divided into two parts. Okay, let's say this is A. And look at here, since this is an isosceles triangle, it must be divided 30 and 30 as well. Oops, it's not degrees, sorry. So it is A, so it must be 30 minus A. And this must be 2A here. Again, 2A here. This is 30 minus A here, and that's it. So 30 minus A over 30, okay, 30 minus A over 30, 30 minus A over 30, which is equal to 2A divided by 15, right? 2A divided by 15, because remember, this will bisect as well, 15 and 15. So this is half, this is 4A, 5A is equal to 30, and A is equal to 6. So what is the area? So one side is 12, so 12 square is 144. In this one, okay, we can think that that's a parallelogram, special parallelogram, which is called rectangle. It says the area of this rectangle is 56, CF is 2, what is X in centimeter? Okay. Do we know the length, do we know the area of this rectangle? Not yet. But we know that these are parallel as well. Okay. Let's say this is A. This must be A, remember. And it says AHKA. This is 56. Do we know the area of this rectangle? No. Do we know area of this rectangle? No. But again, remember, if there is a point inside the rectangle like this one, so it will divide according to, okay? It will divide accordingly. Let's say these are B's as well. Let's say this is B, and let's say this is B. So as you see here, it is A plus B plus 56, and this is A plus B plus, so it must be 56 as well. So 56 is equal to 2 times X, so therefore X must be 28. This is a rhombus and this is a square, okay. If one of the sides rhombus is 15, so this must be 15, this must be 15, this is X, this must be 15 minus X. DE is 3. As you see, EF is parallel to GH, therefore it's parallel to AB as well. Oh, perfect, because it's 15, therefore DC is 15. So DA must be 15, therefore this is 2 on 12. So therefore this is 9 from Pythagoras again. 9, so it must be 6. That's a quick question, huh? Okay, let's look at next one. It says 6 square, this is 1, this is 5. So what's the area of the square in centimeter? So let's say this is 3. 3 plus 1, which is 4, okay. 3, 4, 5, it satisfies the condition. Therefore, 4 square, which is 16. And the last question of test 6, as you see, again, E is the midpoint of this line segment AD. Extend it, okay, extend it and extend it through here as well. So as you see, this triangle here and this triangle here are congruent. It is 12, this is 6, this is 6, and it is 12. So therefore, this must be 12 as well. So 12, 6, 6 root 5, 6, 12, again 6 root 5. So therefore, line segment AG must be 6 root 5, must be minus x. And according to point G, as you see, this triangle, upper triangle, and this small triangle, lower triangle, is similar triangle. And it says BF is equal to 2AF. So this is 8, this is 4, this is 8. Okay, then I can apply the similarity. As you see, it is 12 root 5 minus x over x, which is equal to 24 over 8. This is 3, so this is 3x, 4x. 4x is equal to 12 root 5, and simplify again. X is equal to 3 root 5, which is, where is it? 3 root 5 here. It is choice C. Okay, see you guys in the following text. Thank you, bye bye.